From the News Channel 5 Network, this is Open Line.
Hello, everyone. Welcome to Open Line. Glad you are with us tonight. Wednesday night. It is February 24th, 2021, and we're talking about I'm excited about tonight's topic. We're talking about Mars. The Mars rover, Perseverance. Obviously, we all saw that video of it landing not that long ago. We're going to be talking tonight with Dr. David Weintraub, professor of astronomy, Vanderbilt University. A chance for you to call in, ask your questions about what's going on. I'm certainly going to ask questions about what they expect to find, what's happened since that landing. Just get a sense of what's going on up there. It's such a fascinating topic and such a interesting thing to be discussing. So let's bring in right now Dr. David Weintraub, professor of astronomy at Vanderbilt. Thank you so much for being with us.
With you, Ben.
And you're via Zoom, and I love the picture in the background. Very, very calming, and we appreciate that. All right, let me ask you this. So we all saw this video of the landing. What has happened since then? Kind of what's going on up there with the rover, the Perseverance?
As with all missions, once you get where you're going, you need to test out all the systems. Make sure the batteries work, use the solar panels to charge up the batteries. So NASA has several weeks worth of just engineering tests to make sure everything's working. Test the software, test the hardware, shake the limbs out a little bit, stretch the wheels, roll it a bit, just to make sure it works. So there's no science happening right now. Most people have probably seen a picture or two. Today we got this high spatial resolution panorama of the Martian landscape. That tested out the camera, it works. It tested out the communication system, it works. It let the engineers back home, the software guys, test out their software to take 142 pictures and put it together in a mosaic that just looks like this fantastic picture. So they're just testing everything out right now.
Testing everything out. The key objectives of this mission are what?
The main objective of the rover is to look for evidence to find out whether Mars did or did not have life billions of years ago, to look for fossil evidence of life. We're not looking for life that exists today, but looking for evidence that life could have existed billions of years ago.
There's no question that there were rivers, right? Am I right in saying that? There was water on that planet at one time.
That's absolutely right. There's lots of water on the planet, right, in the past. There's no flowing water on Mars now. It's too cold. But in the past, there was lots. And where the rover landed, it's in a crater called Jezero Crater. Jezero Crater is an impact crater. An asteroid hit Mars and made a big ball, but a river flows into this crater. And people should think of it as being the interface region, like where the Mississippi River flows into the Gulf of Mexico. It's a delta. It's where the river flowed into this crater and deposited all these sediments that the river would have carved out of the land and washed down into the crater. So it's a sedimentary region where sedimentary rocks would have formed on the bottom of this big lake billions of years ago. And if there was life in the streams and little critters died and fell into the sediment and the sediment washed into the lake, those sediments would have formed into sedimentary rocks and would be preserved in some form in those rocks.
So they've picked an ideal location. And I am no scientist, but it seems to me if there were large bodies of water and lots of water on the planet many years ago, it seems there would be life, some form of life. Does that, what do you think?
Water doesn't guarantee the presence of life, but if you don't have liquid water, life as we know it would be very tough. So life is the first ingredient you would look for if you think an environment might have been hospitable to life. So we know that on Mars, billions of years ago, Mars was warm enough and wet enough to have rivers and giant lakes and seas and precipitation, which is the first ingredient for possibly having life. We also know that Mars has all the other ingredients that the Earth has that you need for life: carbon, nitrogen, oxygen, magnesium, all those basic building blocks of the molecules of life are on Mars. So if you think of all those ingredients as being your kitchen shelf, your pantry with all the spices, just because you have the spices doesn't mean you can cook something well. But if you don't have the spices, you can't cook, right? So Mars had all the ingredients for life, and it had the warm, wet conditions that would allow life to form and evolve, but we don't know if that happened.
And so we've landed the rover there in this ideal location. We have been talking about, is there life on Mars, I feel like for the better part of my life. When do you think we will know? So let's say, again, everything goes well with this rover. Will this rover tell us conclusively, yep, there was life, or not?
No. It's very unlikely. It's possible. All sorts of things are possible, but very unlikely. So the rover has a camera, and one could imagine that there were large life forms, critters in the ocean that fell to the bottom and formed big fossils in the rocks. And that one of those rocks would be cracked open perfectly so that the rover would take a picture of a fossil. That's very unlikely. And it's unlikely Mars ever had life forms that were large enough to form those kinds of fossils if it had life at all. So what the rover's looking for are rocks with chemical signatures that look unusual in the sense that those chemicals might not have formed in the rock if life weren't there to make that happen. So the rover has the ability to analyze the surfaces of rocks to see what their chemical composition is, but it's very unlikely they'll suddenly discover a DNA molecule. Right? They're going to find chemical evidence that says this sedimentary rock looks really interesting and has organic molecules in it. Organic molecules mean carbon, oxygen, rocks that have carbon and hydrogen in them. Those are organic molecules in which, those are the building blocks of just about everything in your body.
Right.
So if you don't have carbon and hydrogen rich molecules, then you're unlikely to have life that we would recognize. If you do have carbon rich molecules like methane, that doesn't mean methane came from life, but it certainly could have. So if they find molecules in the rocks that look like they could be associated with life, that's a clue. And what the rover is designed to do, which I think is truly fascinating, and long-range planning by NASA and the scientists involved, is the rover has 38 tubes in which it's going to collect sediment. So 38 times, or hopefully more than 30 times, the rover will find a rock that it really likes and says, I really wish I could have this rock in my laboratory back home to look at it under a microscope and take thin sections and see if we find life. The rover is going to drill into that rock and take a tiny little sample and put that sample in this tube and then leave the tube on the surface of Mars. And it's going to drive around and collect those tubes 30 plus times, collect them all in one or two places, and let us know where it put them, where the stash is. And in a few years, NASA hopes to send another spacecraft to Mars that will go down to Mars, scoop up those tubes, and bring them home.
Fascinating. That's fascinating. And now I was also very interested to learn, we're so focused here in the United States on the United States, but others are up there right now, other countries, right? And even in this month, who else is up there and what else is going on?
China sent a spacecraft to Mars, and it is successfully in orbit around Mars. And the United Arab Emirates sent a spacecraft to Mars, which is also in orbit around Mars. All three missions were successful. They have very different goals with those three missions. Something listeners should understand is Mars is hard to get to. It's a long ways away. And the Earth and Mars orbit the sun at different speeds. And every 2 years, approximately, the Earth and Mars are in the right relative positions that it's a good time to go to Mars. So we launch things to Mars every 2 years. So last July was the optimal time to launch something to Mars. If you launched in June or August, it was too expensive in terms of energy and time. So you don't do it. You go last July. And if you go last July, you get there in February. 2 years from last July will be the next opportunity to go to Mars, and we'll probably see several more launches to Mars. So every 2 years, the launch window opens to Mars. And China has sent missions to the moon and successfully landed missions on the surface of the moon, at the south pole of the moon, and on the far side of the moon. And China decided that they were going to prove that they could send a spacecraft to another planet. And they've done that. They've now sent a spacecraft into deep space, as we call it, to Mars. The spacecraft is in orbit, and the Chinese spacecraft not only has an orbiter, it has a lander. So eventually it will drop, it'll split in two, and a piece of it will descend to the surface. And not only does it have a lander, but if the lander lands successfully, the lander has a rover. So they have an orbiter, a lander, and a rover all in one mission. What the Chinese are trying to do is prove they can do this. It's much more of a proof of our abilities mission than it is a science mission. But if they succeed, they'll still do some science while they're at it. The United Arab Emirates is an even more interesting situation, in which they decided they wanted to have a space program. So they started one, but they didn't have 50 years of experience with aerospace engineers, so they hired a bunch. So most of the people who have designed the UAE mission to Mars are American aerospace engineers and planetary scientists who are working with the UAE, but the UAE is trying to train their own people so that they can slowly grow into this and truly have their own people running their own space program. So they had this built as a training program, and then a Japanese rocket launched it to Mars.
Fascinating. So because of where the Earth and Mars line up during this time, this is truly kind of the height of the tourist season in Mars. We have all of these there.
Absolutely.
Now, are we working, do you feel like these United Arab Emirates, China, are they working together, or is there a race to do things, or is it just kind of China trying to crow about things? Are we working together on things, or are these countries all kind of working separately?
Everybody's working separately. I think it's a healthy competition, but those three programs, for the most part, are working separately. Now, the UAE is building on a tremendous amount of knowledge, skills, and experience of American scientists and engineers to build their program and to train their own people. So in that sense, there's international cooperation. But it's really their mission. For the NASA mission, we're not cooperating with China or the UAE, but there are instruments on the rover mission which are not coming from the United States. They're scientific instruments that are built by scientists from Norway, maybe Sweden, Scandinavia somewhere. Another one, I think, was built by a team from Germany. So the NASA mission is an international project with scientists from a lot of different countries.
How soon do you think we could land somebody on Mars, a human being, like in the movie, Matt Damon? How soon can that happen, in your opinion?
I think it's likely by the end of this decade. Now, NASA is not ready to do that. NASA has a plan to send humans, astronauts, to the Mars system in the 2030s. I don't know whether they can pull that off, but even with that, they're talking about sending people into orbit around Mars and bringing them home, not sending astronauts to the surface of Mars. But Elon Musk and his SpaceX space agency, Elon Musk is planning to send astronauts to the surface of Mars. And my bet is that he will have the rockets that are capable of doing that by the end of this decade. He originally was talking about 2024 or 2026. That may be getting pushed back a little bit now. But I think within a decade, we will be able to send people to Mars. Now, there's a caveat to that. We won't be able to bring them home.
That's interesting. Yeah, that is interesting.
I'm not sure we can keep them alive on the surface of Mars, but the answer to your question is within a decade, we will have the ability to send human beings to the surface of Mars. We may not have the ability to keep them alive there or to bring them home, but we can get them there.
Then it may be tough to get people to volunteer to do that, based on what you just said. But what is the end game? I mean, what do you think the future holds? Is Mars, is it a realistic place for us to colonize, or is this just about doing things because it's there and we want to conquer it?
I think that depends on who you talk to. So again, Elon Musk would say, we're going to colonize Mars. We're going to turn Mars into an Earth-like place where we can live, and we're going to do it in this century. I don't think that's possible, but I don't have the answers. I think we have a tremendous amount to learn from Mars about the possibilities of life in the universe. Mars is the closest place in the universe beyond the Earth where life might exist or have existed. I think scientifically, that's a profound experiment to do, to try to find out whether there is life or was life anywhere beyond the Earth. I think we have a tremendous amount to learn about Mars, about the environment. As we talked about earlier, Mars used to have rivers, Mars used to have weather, Mars used to have lakes and seas, Mars used to be warm and wet. And now the average temperature on Mars is 50, 60 degrees below the freezing point of water. It's a hostile environment for life. What happened to Mars? How did Mars go from being an Earth-like planet to being a Mars-like planet? If we can understand that, we might learn something vitally important for taking care of our own planet.
And just a couple more things, then I'll start taking calls. What is your opinion? What do you think? Was there life up there? Will we eventually find that there was life?
I'm going to play my scientist card and say that kind of speculation doesn't really help us. What really helps is to do the exploration and find out. What we know is that Mars had an environment that was hospitable, was conducive to life. We know that on the Earth, we had an environment that was conducive to life, almost identically to Mars' environment, for the first billion, maybe billion and a half, maybe 2 billion years of Mars's history and Earth's history. The two planets were very, very similar. And 3.5, 4 billion years ago, on the Earth, life was formed. It didn't take long after the Earth and the Sun formed for life to get started on the Earth. And if it was that easy for life to get started on Earth, then why shouldn't it have been similarly easy for life to get started on Mars? I think that's the way a lot of planetary scientists and exobiologists think about Mars, that Mars had an environment in which life could have formed. And if the formation of life is not that hard, then life should have existed on Mars. But we have no examples of life beyond the Earth to know whether the formation of life is easy or hard.
And is it a cautionary tale? I mean, what did happen to Mars? If they were so similar, you had lakes and rivers and large amounts of water and weather, what happened to make Mars what it is now?
Obviously, Mars changed. Mars seems to have lost a good bit of its atmosphere. The atmosphere on Mars is very, very thin, more than 100 times thinner than the Earth's atmosphere at the surface. Mars' atmosphere probably was thicker in the past. It held in heat better in the past. The atmosphere acts as a blanket to insulate the surface of the planet. Mars lost the gases in the atmosphere that enabled it to have an effective greenhouse atmosphere. So it froze. What we don't know is how much of Mars's water is still inside Mars, but it lost a lot of its water also, because Mars's gravity is smaller, because Mars is a smaller planet than the Earth, so it can't hold on to its atmosphere as easily as the Earth. And that may have been all the difference, simply because Mars is a little bit smaller and a little bit further from the sun. Its gravitational strength is a little bit weaker, so its atmosphere gradually leaked away into space. And bit by bit, it lost the ability to be a warm, wet planet.
Wow, all this is so interesting. And we've been on before a show that I really enjoyed, talking about the ethics of all of this. If there is, I guess, is life, biotic life, very, very small life forms, what are the ethics of us going up there? That's going to be my last question to kind of encapsulate what you were talking about, because it's fascinating. And then I'm going to start taking calls. We'll go to break and I'll start taking calls. But the ethics of this, what are the ramifications?
NASA has an office called the Office of Planetary Protection. So there are people in important positions within NASA who talk about this stuff. But I don't know what the answer would be. Certainly NASA, as part of their mission, is to protect other worlds if there is life, but that doesn't mean hands off. I would like to think it would mean hands off, but I think to most people it doesn't. I think it depends a lot on what we find. If, and it's a big if we found fossils of life in the soil, that doesn't mean Mars has life now. It would be fascinating as a discovery, but there's a difference between life that was there 2 billion years ago and life that's there now. If we drilled down in the soil and found that there's life beneath the surface, that life is going to be bacterial or viral type life. It's going to be tiny little one-celled creatures, most likely. We're not going to find worms or teddy bear or gorillas or polar bears wandering around there. We're not going to find macroscopic life. And I'm not sure people care that much about bacteria on Mars, other than, wow, that would be life on Mars. Scientists will care a lot, but do we need to protect it and preserve it? If, in fact, one of the things on this rover mission is a little helicopter, I mean, it's a little 4-pound helicopter, and that's a pure engineering experiment to see if we can fly a helicopter on Mars. But if we can, then one of the next steps, you'll see where I'm going with this, one of the next steps will be to build a mission in which, think of it as a bat cave, right? You send a mission with hundreds or thousands of these little drone helicopters, open it up, and whoosh, they go fly around Mars with little cameras to explore. And they find caves on Mars, and they go fly into the caves as drones to see what's inside the caves. And if one of those flew inside a cave and there were some little creatures with little red eyes staring back at it, I think the conversation would change pretty dramatically. I don't think it's likely that that will happen, but that's a next step in exploring Mars, to have those little, hummingbird things fly around Mars and explore for us, to explore vast areas on Mars that the rovers can't get to. And then maybe we'll find something even more interesting.
And the history of exploration here on Earth is one of explorers going to new places and really wreaking havoc, right? I mean, bringing disease and really destroying what it is that they come to inhabit. And we kind of want to avoid those kind of mistakes.
I think we want to avoid that. So the spacecraft that are sent to Mars are as sterile as we can make them. That doesn't mean they're perfectly sterile. We may have still sent some creatures there, but we're trying to protect those environments to the extent possible, because I think if we did send human waste, human, biology of all sorts, terrestrial biology of all sorts to Mars, we would contaminate Mars. And I doubt Martian life could compete with us. So we would wreak biological havoc on that environment if there is Martian native biology to compete with.
Fascinating. Okay, we have to take a break, and we have a bunch of calls. So I'll stop asking questions, but I hope that sets the table for everybody. So if you're on the line, hold on. If you want to call in, there's the number, 615-737-PLUS, 615-737-7587. We'll take a break. Be back right after this.